Okay, see. So we have a capacitor here, and say there is a charge on the uh, capacitor already existing. So what charge should I take? Say plus, minus. So plus CV and minus CV with the initial charges, all right, on the capacitor. Already it is there. Now this capacitor, also this capacitor had a capacitance of C. Now this capacitor is connected. Question is clear initially, capacitor is already charged. Okay. Now the capacitor is connected to a battery like this, which has a potential of CV, right? Now it is told find charge flow through the battery, find charge flow through battery. This is the first one. And the second one is charge flow through the battery, and the second one is generated in the circuit. Okay. So you all remember how to do it, or shall I show you again?
Can you show this one?
Yes, sir.
Take the left plate of the capacitor is charged plus CV and minus CV. This is logical because we had discussed that the plates of parallel plate capacitor are always same and oppositely charged, like plus 20 coulombs, minus 20 coulombs, like that. They always occur in pairs, plus and minus. This much is clear. So therefore, plus CV, minus CV. This much is okay.
Yeah.
Yes.
Okay. Now you see the final condition. This is the initial condition which is given in the question. If I try to draw the final condition, it will be something like this. You only tell me that if the capacitance is C, what will be the final charge on the left plate of the capacitor as per this condition? As per the condition given, what will be the final charge on the left plate of the capacitor?
Plus 3 CV.
Plus 3 CV. No, actually minus 3 CV, left plate. It's connected to negative terminal.
So yeah, minus 3 CV.
Minus 3 CV. Okay, understood everyone?
Yeah.
Minus 3 CV hoga charge because Q equals to C into V. So minus 3 CV and right one will have plus 3 CV,
Plus
alright?
3 CV.
Okay. Now look at the initial condition. Initial condition shows that the left plate had a charge of how much?
Plus CV.
Plus CV. And now the final charge is
Minus 3 CV.
minus 3 CV. So how much charge must have left this plate? Charge came or left?
Left.
Left. How much?
Minus 2 CV.
No. CV was
Minus 4
initial.
CV.
4 CV charge left. That's it.
Yeah.
Clear this much?
Yeah.
Sure. सबको clear है? साराक्षी clear?
हाँ सर, clear है.
So 4 यहाँ से 4 CV must have flown. Then only this condition will be achieved. 4 CV. Then CV minus 4 CV will be 3 minus 3 CV that will be remain. Okay. The first question, find the charge flown to the battery, is very simple. How much is it? 4 CV. Okay. Now the second question is work heat generated. So the formula for heat generated we had seen last class. What was that? That heat is equals to work done by the battery plus final energy minus the initial energy, right? Right or wrong? You all remember this? Sorry,
This is
it
I
will
think
be
wrong.
minus.
That will be minus.
Yeah, this is minus. All right. Much
Yes.
you remember?
So yeah.
Because the work done by the battery, whatever is there, actually this work done by the battery equals to delta U. Work done by the battery will have two contributions. One in increasing the potential energy, and another one will go as heat. From there we get the formula that heat equals to work done by the battery minus by U. All right. So what is the work done by the battery in this case? We need to find the heat. What is the work done by the battery? You all tell. Or if you all don't remember, then you refer to the notes and tell me. 4 CV charge has flown to the battery 3V.
So will it be 4 CV square?
Battery is of 3V.
3 CV square.
So what is the charge flown? 4 CV, right? And the is flown through battery of 3V. So work done by the battery was QV. We had discussed. Don't remember? We had discussed lots of questions. See. See.
Yeah.
So in this case, question number 2. When 5 coulomb charge is flowing through a battery of 10 volt. So what was the work done by the battery? Plus 50. Charge multiplied by V. Similarly, in
Yeah.
this situation, question number 1. When 2 coulomb charge is flowing from positive to negative terminal, opposite. In that case, work done by the battery is negative. Battery is getting charged actually. Battery is getting energy, it's not used. So it will be work done is minus 20. Again, Q into V. Yes or no? We have discussed this.
Yes.
Yes, sir.
Therefore, here what is the work done by the battery? 4 CV is flowing through 3V.
12 CV square.
12 CV square. Yes. So 12 CV square. Very good. Minus. What is the final potential energy? Which formula we will use to find potential energy of the capacitor which has a charge of at this point of time 3 CV. Positive plate has a charge of 3 CV. What formula
So
can we use?
half C3 CV square.
Half CV square also we can use it. So let us use half. But remember when you are using half CV square, half C and V square will use, it will become 9V square, okay?
Yeah.
It becomes so because entire 3V is applied across C capacitor. Entire 3 volt is across that C. Okay.
Yeah.
And I said this statement because if one more capacitor would have been here, say for example C2, then half CV square you can't write V as 3V there because some 3 volt will be here across, some portion of the 3 volt will be across here, some portion of the 3 volt will be across here. Means this 3 volt will be split into, this 3 volt will be split as potentials across C1 and C2. Understood or not?
Yeah.
Yes,
So
sir.
because here entire 3 volt is across that C capacitor, therefore half CV square we are writing V as 3V whole square. So we got here final as this much. Okay, and initial was how much?
Half C2 3V square.
Oh. Therefore, because it is see when you write half CV square, so initially, uh, initially this C must have been connected to some V. Therefore, the charge was plus CV minus CV. This is the initial condition. Getting it or not?
Yeah.
Initial condition must have been like that. So therefore, rather than writing minus half CV square, you can better write it the format of Q square by 2C because Q is known as CV. So you can write Q square by 2, no problem. One you can use half CV square, another you can use Q square by 2C, no problem, it will give the same. Understood or not understood?
Yeah.
Yes,
Understood.
sir. Understood.
See there you can't use half CV square, half C into 3V whole square, that's wrong. Because that is not, that is the transitional phase, that is not the initial phase. This diagram is a transitional thing. It is not the final state. It's going to change. This changes to this. Therefore, half CV square can't be applied there. Got it, no?
Yeah.
So, okay, fine. Here what we get. So this is 12 CV square minus. This is how much? 4.5 CV square, right? minus, this is half CV square, 0.52. Okay. Yes, that is 12 CV square minus 4 CV square, that is 8 CV square. Everybody understood?
Yeah.
Yes, sir.
The heat generated. So I'm giving you one question and go solve. So the capacitor that is charged like minus 2 CV plus 2 CV in this fashion. It is connected to a battery and connected to a battery like this. This is equals to P. The terminals will be connected in this fashion to the battery. So find the charge from wire, work done by battery, quickly solve it.
सर नीचे सिर्फ बी दिया हुआ है.
Can be.
ओके सर.
What is the charge flown? अच्छा capacitance of the capacitor is तो दिया ही नहीं. What you have taken? You have taken something or not? Take it, see.
सर सी लिया है.
What is the charge flown? Sarakshi got the answer or not? Charge flown in the wires.
Sir, 0.
Your voice is coming very. Okay, I'll show you. What is the final state? Let us draw the final state. The final state will be somewhat like this. Because this is B and this is C, this is the positive plate. And this is the positive side of the battery. The side which is connected to the positive plate will have how much? Plus CV. Then capacitance into V. This will be minus CV. So charge flown in the wires will be CV. Because initially it was 2 CV here, final became CV. From 2 CV to CV.
1 CV.
CV must have been flown in this fashion. That is the first question. Work done by the battery will be, because CV is flowing in this direction, so it will be minus CV square. Okay, understood? Minus.
Yeah.
And delta U for the capacitor will be. So final is certainly, you can say Q square by 2C also. So square by 2C final minus the initial one was Q square by 2. So this is 1 minus 4 minus 3 by 2 C square. Okay. So delta U for capacitor is minus 1.5 CV square. Heat generated will be work done by the battery minus of the heat, minus of the delta U. That is 0.5. And work done by the battery is, sorry, heat generated is work done by the battery minus delta U. Work done by the battery is minus CV square. Minus of delta U is how much? Minus 1.5. That is minus CV square plus 1.5 CV square. That is 0. Okay, understood?
Yeah.
We'll move on to the
Yes, sir.
next kind of questions. Now let us say there is no battery, but there are two charged capacitors. There is one capacitor, here is one capacitor. Let us say this is 2 microfarad was charged, so it is plus 20 microcoulomb minus 20 microcoulomb. All right. So this is the charged capacitor. There is another charged capacitor. This has, okay. So first, this charged capacitor, it is 20, plus 30 microcoulomb minus 30 microcoulomb, and this is 8 microfarads. So now they are two independent capacitors, all right, and they are charged. Capacitor means they hold charge, right? Capacitance is the capacity to hold charge. So they are holding their individual charge. And now their individual terminals are connected to each other in this manner. They are connected. So once they are connected, charges will certainly flow, right? Will flow or not?
Yeah.
See how why the charge will flow.
Because of potential difference.
Okay, what is the potential across this capacitor right now? What is the potential difference? P1. What is this potential difference? We know Q equals to CV, right? So V is Q by C. The potential difference across the capacitor, right? Out of which Q is the charge on the positive plate we had discussed, and the capacitance is 2, right? It is 10 volts.
Yeah.
Are actually clear?
Yes, sir.
Potential difference for the above capacitor is 10. For the bottom capacitor will be how much? For the bottom capacitor will be how much? Tell.
30 by 8.
30 by 8. Very
30
good.
by 8.
Very good.
So 3
Q
point.
by, yeah, correct. So something 3 point something, right?
Yeah.
60 is 75. It's the 8.3.75. So we see that there is a potential difference across these capacitors. The charges will certainly flow. The charges will flow. See, because why the charge is going to flow? Because certain final condition is logically because these capacitors are connected across same potential. Take this potential and this potential point in this point will also have a potential of point will have a potential. Okay. Ideally speaking, both the capacitors should have same potential difference, right or wrong?
Sorry, sir, what did you say?
That both the capacitors should have same potential difference. Both are AB only for this only the potential difference is AB. Capacitor also then it should be VAB only. So they're same points.
Yeah.
It's logical, but they're connected across same points.
Yes, sir.
They're
Yeah.
connected. They're basically in parallel. Parallel means the same. Both across we see VAB is only there. But here the potentials are different. So therefore the charges will flow so long the potential doesn't become equal. Therefore this is not final state. This is the initial state only. This is just the
Yeah.
initial. After that the charge has to flow till it achieves this condition.
Yeah.
So now how will we solve what is the charge that is flown that we have to find? Okay. Try one. Think of a way to solve it. Question is find the final charge. This is not this is the initial charges. Two capacitors charged, they are connected. Capital the final arrangement of the charges on the capacitor. My voice is audible if I'm speaking at this volume.
It is audible.
Try to think how to find.
We have to find the final what?
Final charges on the capacitor. Find the final charges on the capacitor. Any idea how to do?
I found the initial charges on both of them using CV.
If the initial charges are given 20 microcoulomb minus 20 plus 13. How to get the final? See, when they are connected, some charge will flow. This much is clear. Right or wrong?
Yeah.
So if some charge is, can assume the charges to be flowing. Yes, please. Charges are going. We don't know in which direction. Let us assume that this fashion. Few charges flow in this and this direction. Any harm? No harm. Okay. Two charges flowing in this fashion. Then we like whole circuit. Clear so far? Now, the clear not everyone.
Yeah. It's clear.
No, focus on this positive. Two charges. Good. Total positive. Array, Q20 micro charges from how much will 20 minus simple. If you have 5 bananas, I take 2 bananas. How many bananas you?
Okay, then on the other side it will be 30 plus 2 like that.
30. Array, 30 coulomb charges there. Charges arrive. 30 plus. Right or wrong?
Yeah.
30 plus. Now one thing you have to ensure that it 20 minus of right. They are oppositely charged. Okay.
Yeah.
So I just wrote in this fashion, explain you the things. But, all right. The final charges, right? This is the final charge distribution. Now we need to find how we will get started that when there is a resistor R and current is I, and when we are going in the direction of current, there is a potential drop IR, right?
Yeah.
Yes, sir.
Similarly, we had seen that from lower potential to higher potential at the terminals of a battery, potential fashion by 10.
Increase by 10 volts.
Similarly, when higher potential, lower potential will
Minus 2.
is better. Now let us particular question. Always this is applicable what I'm saying. Let us start our journey from there. Start our journey. A. All right. Start our journey from. We'll move in this fashion. We'll make a complete loop and we'll come back at this point. Okay. So basically, we are moving
Yes,
from
sir.
A to A. The total potential difference is right or wrong.
Yeah.
Array, a circuit is never complicated. We travel from this point. Keep on writing minus IR plus C minus IR plus C. If you reach back at this point only, I'm writing something like A plus so on, so on, so on, so on, and finally we write what? This much is equals to VA. We write this, right?
Yeah.
Started series is A. We wrote VA for this something. We wrote for this something. Finally we wrote equals to V. VA gets cancelled, right? So whatever remains, its summation should be 0. Right or wrong?
Yeah. It's right.
Are they understood or not?
Yes, sir.
तो यहाँ से A से अगर start करेंगे, तो start करेंगे and we write down the potential of all the different components that can come back at A. should be equal to 0. Okay, remember this. It's called Kirchhoff's loop law. It's called Kirchhoff's loop law. Let us go in this direction. So when we are going in this direction, this one is a positive state. This is a positive state. The negative. It was as per the question. The question, this was a positive state, right? The positive state initially.
Yes, sir.
Assume that as a positive, and one also will assume positive state. So this clear to everyone so far. Okay. When I'm crossing this capacitor, I'm going from positive to negative or negative to positive. This fashion, left to right.
So positive to
Positive
negative.
to negative.
Positive. Positive to negative means potential drop, right? Higher potential to lower potential. Okay. So what is the potential drop? Tell me. The potential difference across capacitor. Q equals to C into V by C. Q is 20 minus Q by C. Okay. That's good or not?
Yeah, understood.
Yes, sir.
Just written P as Q by C. This is the potential drop. So we'll write minus. Don't forget. Okay. All right. Now we cross this capacitor. Now we are coming fraction, fraction, same. Now we'll jump again this capacitor from here to back. So we are going from negative to positive, right?
Yes,
Potential
sir.
will increase. Plus how much?
30 plus Q by 8.
And after crossing, let Q 0 final. In one loop, the total potential difference. From here, can you find out and tell me?
Yeah.
I'm also solving those. Got the answer? How much? Anybody got the answer or not?
Yes, sir.
Okay. Q is 10. What is the final charge distribution? The capacitors. Draw the final charges now. If Q is 10, this means 10 coulomb charge Q in this fashion. And Q is coming positive means we had assumed direction correct. Q would come out to be negative, it means direction would have been like this, right? We had assumed Q in this fashion. Yes or no?
Yeah.
If Q
Yes,
would
sir.
have been negative, whatever we had assumed. Q is coming here, value is 1. So initially it was 20 microcoulombs, so final charge will be how much? I'm drawing here in short. Final charge here will be plus 10, minus 10, they are in microcoulombs, and plus 10 arrived here. So it will be how much? Plus 40, minus 40, right or wrong?
Yeah, it's right.
Yes, sir.
There is 2 farad, 2 microfarad capacitance. So you check the potential difference because both is now how much? 5 Q by C. Check 5 volts. Yes or no?
Yeah.
Yes, sir.
All right. Plus 15. Right. Okay. The initial condition. Okay. Now the charges are going to go. You have to tell the final charge itself. Now this you all have to solve. Till the time you all don't solve, I'll not go ahead. Get the previous question. Try to solve it. Easy question. When I give you all question, you all go to sleep or what? Till the time it is theory, you will respond. When the question comes, then try to solve this one.
Yes, sir.
And Zara likes, seems that after I give a question, Zara goes for a peaceful walk.
No, sir, not like that.
Goes, takes a stroll peacefully and comes back and sits. Okay, now master is about to tell the problem.
No, no, not like that.
Solve quickly.
So again, we have to find the final charges on the capacitor, right?
Yes. Sarakshi done?
So decimal में आएगा आंसर.
नहीं.
एक मिनट.
See, all of you assume that a charge Q will be leaving.
Yeah.
Yes, sir.
Now, what is the final charge on this plate? Speak. Why are you getting quiet? What is the charge on this plate after Q leaves?
That will be minus 15 minus 2.
15 minus Q, right?
15 minus Q. Yes, sir.
पहले 15 था. Q जाएगा तो 15 minus Q रहेगा ना. We have 5
Yeah.
banana. I have to again telling 5 banana. 2 banana will go. How many banana will remain? 3 banana. Same 15 banana there. Q banana left. 15 minus Q banana will remain. It's simple, na?
Yeah.
And here minus 5 is there. Q is arriving. How much will be there?
Plus 5 plus 5 plus 2.
Minus 5 plus Q. Right or wrong? Minus 5 is already there. Q has arrived. So just add the minus 5 plus Q.
Yes, sir.
अरे इसमें बहुत बड़ा तोप मारना था क्या?
No,
No,
sir.
sir, I'm just solving that only. Calculations are left.
Now if this is 15 minus Q, this will be after all minus 15 minus of whatever is there. So it is capacitor, so it has to be negative. Simple, done. Right or wrong?
Yeah.
Now just you have to try, like just write one small equation to get the answer. Now this is positive plate, this is negative plate. See, as per the question, this is positive plate, this is negative plate. When you are writing positive negative, be careful. Yes or no?
Yeah.
As per the plates you are seeing, every time this is for positive plate. And here this was positive. Okay. So one simple equation I will write. What equation I'll write? See, for the above, for the upper capacitor, what I will write? Let us start from this point. Let us, so when I'm moving, when I cross this capacitor, what is the first equation that I will write? For the potential difference, plus to minus I'm going, right? Minus
It's minus 4.
Q by C, right?
Yeah.
Yes, sir.
And I arrived here. I'm coming down. After reaching bottom, again I'm crossing. So I'm going from again plus to minus. Plus to minus means
So minus
minus.
Minus
5
5 plus 2.
plus 2.
Now always remember, I had told you that when you write Q equals to CV, Q is the charge on the positive plate. I told you, I think I remember. Q is the charge. मैं लिखा है तो ऊपर दिखा दूं क्या? Somewhere I must have
No, sir, we remember. You
remembered.
had told this.
Q is the charge on the positive plate. So you have to find where is the positive plate first. Which is the positive plate? This one. Yes, on which the charge is uh, 5 minus Q basically. Right or wrong? Minus of minus 5
Yes,
plus
sir.
5 minus.
Yeah.
I'm writing it. 5 minus. So here
5
we will
plus 2, right?
here see here minus 5 plus Q. So negative of that exact. So plus 5 minus Q.
Yeah.
So minus of charge on the positive plate by capacitor equals to 0. Simple. Are yes or no?
Yeah.
Now you can solve it or not? Or should I give you 4 5 questions like this to solve? Algebraic
No, sir, we can solve.
No, we will solve it.
solve, multiply by question. You know how to solve or that also I'll teach? I can teach it, no problem.
We know.
Do first. Got the answer? What is the value of charge flown?
So minus 120.
क्या बोल रही है? You have to simplify this expression.
I got Q is equal to minus 35.
Once just check the expression which you all wrote and tell me, have you written the correct expression? Okay.
Yeah,
Okay. I give you 1 minute, check your calculations again. All of you check your calculation and tell me. 1 minute. Any mistakes you got or you have solved correctly? Sarah, found any mistakes?
yeah, I did a mistake.
Sarakshi, found any mistake?
Yes, sir.
Karo.
No, I'm getting Q as plus 35.
Check again.
What is the answer?
That I'll not. You have to get the right answer, then I'll tell.
So is it in positive plus or minus?
तो निकला कितना वो बता.
नहीं सर, मेरा माइनस में आंसर आ रहा है, पता नहीं क्यों.
Oh Krishna.
Let me try one last time.
Acha, when was the last time you all studied maths? Tell me honestly. Sarah, I think in your 11th you had maths or not? Anyone?
No,
So I
I'm not
didn't
taking
have maths.
Yes, आप लोग का सब. Therefore, you are having so much of difficulty in your basic calculations. Okay, fine. I'll ask you one question. Tell me. I'm giving you an expression. Try to solve it. X minus 2 by 5 plus x minus 2 by 2 equals to 0. Can you find the value of x? Leave that one. Solve this one. Okay, this one I'll teach how to solve. All of you are able to see this expression?
Yeah,
Yes,
How
sir.
will I solve? I can do one thing. I can take the LCM. Take the LCM as 10. 5 into 2 is 5 2 is 10. So I took the LCM as 10.
2x minus 4 plus 5x minus 10.
So it will be 2x minus 4. Wait. I'll show why the very big. 2 into x minus 2 plus 5 into x minus 2 equals to how much? 0. So this will be 2 into x minus 2 plus 5 into x minus 2 equal to 0 multiplied by 10. Yes or no?
Yeah,
Yes, sir.
So इसको bracket खोलेंगे तो 2x minus 4. I hope you know how to open the brackets. 5x minus
so
10
x
is
is
bracket.
equal to 2.
Huh?
Final answer x is equal to 2, right?
X equals to. Got it?
Yeah.
Okay.
Yes, sir.
solve it. So solve them.
I'm getting x is equal to 1 by minus 3.
1 by
Minus 3.
कराची हो गया.
Sir, एक minute.
This question I will do like this.
So 9/28 ऐसा कुछ आ रहा है.
This much is clear to everyone.
Yeah.
Yes, sir.
Minus वाला को उधर लेके चला गया, so I can directly just cross. When cross multiplying will be easy. So 7 to the 14. And minus 2x plus 4 should be equal to x minus 5. So I'm getting 3x equals to 9. I'm getting. Yes or no? Minus 5, it can come here, it will come plus 5. So 4 plus 5 is 9. 2x will go that side. X plus 2x is 3x. X equals to 3. Yes or no? X equals to 3 is the answer. Yes or no?
Yeah.
Yes, sir.
One more question.
Y is equal to 15 by 4 for the question 3.
10 by 3.
4.
Sir, half आ रहा है.
Okay, solve question number 4. Let's. Fifteen by 4. हाफ कैसे आ गया तुमरा?
गलत हुआ सर.
Question number 4 do quick. If you all do mistakes here, then to finished. So writing correct equations will also get wrong value. Question number 4 solve quick. Tell me the answer. Sarah got the answer of 4.
I'm solving. Last part is At the end, it's coming 4y is equal to 3y. So it's
4.
not defined. 4y is equal to 3y. So it will be not defined, right?
Oh, so become like that. I will
I did 2y minus 5y6 is equal to 3y minus 10 by 12. So 6
3y
2s
minus
are
10 by
12.
12.
Yeah.
Hmm.
So 6 2s are 12. Then 2 goes
Wait,
there.
wait, wait,
Then
wait,
we
wait,
get,
wait, 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 wait. All right.
and then 2 goes there. 4y minus 10.
Uh,
Then you get 3y minus 10.
uh,
So minus 10 can get cancelled.
okay,
Then you get 4y is equal to 3y. So it will be not defined.
okay,
Because then if you take 4 over there, y is equal to 3y by 4. Then again, y will get cancelled. So you get 0 is equal to 3 by 4.
no, 4y equals to 3y, right?
Yeah.
What is the answer of this? 4y equals to 3y. And y has to be 0x. There is no other correct. Okay. It is not undefined. We can get a solution as y is 0. If y is,
Yeah.
if y is 0, you put here. You'll get minus 5 by 6 on the left hand side. On the right hand side, you put y 0. Get minus 6. Yes or no?
Yeah. Yeah.
There is a solution. Okay. Okay, let us come back to this. Okay. Now solve this one again. This part. If you put your own answers there, no, the value of q that you have found, it will not match. You can check your own answers also. Solve it quickly. You have 1 minute.
So I took the whole term minus 5 minus q is equal to 3 by 3 on the other side. And
Answer
then here,
answer what you got.
I'm just calculating the last part.
রাখছি হচ্ছে
স্যার করছি
till class 10th you all studied maths or not? Till class 10th also
Yeah.
you will sacrifice.
Now I'm getting q is equal to 11.
Now it's correct. Now you all can see what all miracles you have done previously. Try to find out
Ah,
what mistakes you will get. The answer is q is 11. My lord, you all are dangerous people. It's simple calculation you see. Q is 11. Yes or no? right? So now tell what is the final charge distribution. Sarakshi got a 11 or not?
सर अब समझ में आया कहाँ गलती किया मेरा। ठीक है सर, हाँ समझ में आ गया, पर हुआ था पूरा ये वाला लेकिन लास्ट में।
पूरा डाउट है हमको तुम लोग। अच्छा, you all got 11 coulomb. If you get 11 coulomb Q, then tell the final charges. वही बताना पड़ेगा क्या?
No, sir.
Final charge will be 15 minus 11. That is equals to 4. Yes or no?
Yeah.
And 11 coulomb is reaching down. So final charge is 4 here minus 4 here. At the bottom capacitor, what will the final charge here?
Plus 6 and minus 6.
Minus 5 plus 11 is plus 6 and minus 6. Yes or no?
Yeah.
This is the final charge distribution. Understood?
Yes sir.
So you all gave me a big mental trauma. Okay. Anyway, I'll overcome it by one. So one more question we'll solve, okay? Now we'll take 3 capacitors. Concept remains same only. These kind of questions are just to make concept clear, that's all. It's not to mug up or not to big boast about that big capacitor we have learned. Not like that, but it's just to clear the concept. Okay. So initially it is plus 10, minus 10, plus 10, point 0, 0, uncharged capacity. 5, 5, 10. So farad. Right? And the charges are in microcoulomb, not mentioned. So this is the initial distribution. Then you find the final charge. Concept you have to use same, that you can assume that Q charge is flowing. Find the final charge capacity. Shall I do or you will do? Try once.
No, will do.
First write the final charges. I mean, after Q is being flown, tell me the charges, then proceed ahead. And don't feel shy. Tell me quickly so that we can solve more questions. Sarah, you've written the charges after Q is flown. Step.
Instead of writing it like this, I just wrote them in one line. That is okay, right?
Which one line?
All of them like in a one single straight line consecutively. And then wrote the plus and minus values.
But while doing that, ensure that you don't change the polarity of the capacitor.
Yeah, I've written the plus and minus correctly. Left plus and right minus.
Okay, charges Q you have passed and you have written the charges in terms of Q finally. Sir, actually, you have written charges Q finally. I mean, final distribution in terms of Q.
Yes, sir. Writing.
अरे भैया तो कसम खाएगा जुलाएंगे मास्टर
नहीं सर हो रहा है.
इधर देख. Can I imagine Q charge flowing in this fashion? Q charge is going in this fashion. This become 20 minus Q. This will then become minus 20 plus Q. That's the negative of it. Here.
Yeah.
Q charge arriving so minus 10 plus Q. And this will be then 10 plus 10 minus Q. Yeah. Plus 10 minus Q. And the same Q arrives here also. Q goes here. Q and minus. Just like current flows throughout the circuit, you can assume Q is flowing like this. So, okay.
Yeah.
Now let us start from this point, whichever point you want. Let us start from this point and like. So this is negative, basically this is positive. And for this one, this was positive plate, this was negative plate. For this one, positive plate, this was negative. Okay, understood?
Yeah.
So when I'll pass from here, then what will I write? Minus to plus Q by 10. Q by C, right?
Yeah.
And when I pass from here, what will I write?
Minus 10 plus Q by 4.
No. Charge on the positive plate you have to write. And anyhow, you are going from plus to minus. What you said? So you are going from plus to minus, so minus. Charge on the positive plate, how much?
Plus 10 minus Q by 5.
Ensure this thing. Minus is for what? Like going from plus to minus. Charge is on the positive plate like that. All right.
Yeah.
And then when I cross, then after crossing this,
20 minus Q by 5.
plus or minus?
Minus.
Minus. Now you can solve this. How you will solve? See, LCM is 10.
Yeah.
So
Multiply
multiply
by 2.
by 10 to both the sides. So this when I multiply 10, it will remain Q minus. If I multiply this part, 2 into 10 minus Q, that multiply by 10, so minus again into 20 minus equals to 0. Yes or no?
Yeah.
You all can solve. Now you all can solve your own.
I'm getting minus 20.
Minus 20, I'm getting 12. Check once.
Yeah, I got 12 also. 5Q is equal to 12.
Madam,
Yes, sir.
che,
सर एक्सप्रेशन तक आ गया था, बस कैलकुलेशन नहीं हुआ था।
तक कैलकुलेशन तो करना पड़ेगा ना।
हाँ सर।
Calculation practice you all have to do in your home. Q is 12 anyway. The final charge distribution all of you can write down quickly. So final charge on this one will be how much? Q is plus 12, means Q is actually leaving the capacitor. Will be how much? Tell me. Left plate will have charge how much?
8.
Very good.
3.
Plus 8. So this will be minus 8. This will be how much? This one.
2.
Minus 10 plus 12. It will be plus 2.
Plus 2,
So
yes sir.
this will be how much?
Minus 6.
Okay. This one.
This will be 12.
12. Okay.
Minus 2.
Now here it is not necessary that potential across all of them will be same. All right. So they are not in parallel. They are in series basically. There is no mandatory law that potential across them. But yes, potential drop across all of them should add up to. All right.
Yeah.
Yes sir.
One more question you want like this?
No, sir.
नहीं सर, हो गया, समझ आ गया।
समझ आ गया, but कर बेटा एक और कर तू. One last question too. And answer, so long you don't give the right answer, I'll keep on making use of these kind of. And you have to reach to the right answer. 2 microfarad plus 10 minus 10. Initial distribution I'm giving. Just tell me the final charges. That is my only question. Final charge on the capacitor, plate wise. You can see in my screen the time is 4:19. At 4:22, if you don't solve, I'll give 2 more questions like this. No, just joking. But 4:22 it should be over.
I'm getting the formula as 10 minus q by 2 minus 20 minus q by 4 and minus 10 minus q by 2.
10 minus q by 2, then
Minus 20 minus q by 4 because plus
wait,
to
wait, wait,
minus.
wait, wait. So 10 minus q by 2, that is correct.
Yeah. Then minus and then 20 minus q by 4 because we are going plus 2 minus. Then again minus 10 minus q by 2. Again we are going plus 2 minus, that's why.
Can you repeat 10 minus q by 2? I understood then.
Yeah.
After that,
Minus, then 20 minus q in the bracket by 4.
you started from which point?
From 10.
Here,
Yeah.
where, in this fashion or this fashion?
And the other one downwards.
Okay.
Yeah.
Okay. So you are telling 10
Minus q by 2.
by minus q. Which fashion you assume the charge to flow? Charge you assume to flow in which fashion? This way? Huh?
Yeah.
If q is flowing in this way, this
So
will
तो
be what?
plus 20 minus q होगा.
Either 10 minus, this is 10 minus q, clear?
Yeah.
Minus
Yes,
10
sir.
plus q. Minus 20 plus q. This 20 minus q. 10 plus q because q is arriving, right? Then minus 10 minus. Yes or no?
Yeah.
Yes, sir.
Now, if you are flowing in this fashion, so this is minus, this is plus.
So 10 plus q by 2. Then 20 minus q by 4.
Minus 20 minus q by 4
And then minus 10 minus q by 2.
equal to 0. Yeah, solve it. 22 तो यही हो गया. 422. Okay, solve it quickly. You got this? You have got this expression?
Yes, sir.
Little bit here and there, it's okay. But you understood, no, Zara?
Yeah.
Go ahead first. So Sarakshi will give the answer of this question. What the value of q?
I got the answer.
Sarakshi आया?
सर अभी गलत होगा तो फिर से करवाएंगे 1 मिनट.
जल्दी कर. You can send me in chat box your message personally.
Okay, sir. Okay, sir.
Zara can also send her answer you got in chat box personally. Let me. हैं? अच्छा. Okay. Check. I think it's wrong. Check once. Check the calculations once. Let me know. Any other answer?
सर आपको मिला चैट में आंसर?
हाँ मैं देख लिया. आंसर निकाल.
अच्छा सर.
Zara, I check once the calculations. Now you all can shout the solution. Whatever you have got, you all can tell directly. Apart from what you have already calculated, both of you. सही क्या है? Sarah got right. Sarah, you are getting any calculation mistake?
No,
I think I only made a mistake. Minus 20 plus Q. Minus 20 should come 4 because 4 is fitting there. 14 by 2 is 7. 7 minus 16 plus 10. 4 is minus. Yes, good. You should come out to be 4. Okay, understood?
yeah.
Yes, sir.
Okay, no, so I'm not solving it. Okay, now we had studied in current electricity. This kind of problem to remember. Ten ohms, 20 ohm, 5 volt, 10. Can you tell the current through all the resistors in this case? Let's solve these kinds of questions. Find the current through all the resistors. If you can solve this question, then we'll go ahead with capacitors. How to do this question? Anybody remembers? How we do? How we should do it? What was our first step?
We have to take the voltage and then we have the resistance, so we can calculate the Q from there.
What was
So
the first
here
step?
we have to calculate the voltage at every point.
How will you calculate? Yes, it's point-wise voltage, right?
Yeah.
Calculate that. And then tell the current. It's very quick. Tell.
So between 20 and 10 ohms, there will be a 10 volt voltage.
Yes. Let us take 0 here. Okay.
Yeah,
This will be how much?
10 volts,
10 volts. This will be
5 volts,
5, and this will be
5 volts.
yes. What is the current through 30 ohm resistance? Current through 30 ohm.
Q is equal to IR, then
Beta
we have
current. V equal to IR.
V equal. So V by R. So 5 by 30.
1 by 6 amperes. Okay.
Yeah,
Right or wrong?
right.
Direction I
Yes,
have to
sir.
run correctly or wrong? Direction of current is right or wrong? Or it should go like this.
No, it's right.
Why?
Because of the battery.
Because of the
Higher, lower to higher voltage, right?
higher to lower. From 5 to 0 it will flow, right? 5 volt to 0 volt.
Yeah.
Okay, I've drawn correctly, no? It's going
Yes.
from 5 to 0. Understood the logic? From higher potential to lower potential. Okay? Okay, now this 20 ohm resistance, what will be the current and direction? Tell.
So 1/2 ampere
Direction.
towards the zero, so rightwards.
Okay, and through 10 ohm.
Again 1/2 ampere
Direction
towards 0 volts.
towards 0 volt.
Yeah, so right.
Right. सर अच्छी समझ में आया?
हाँ सर
What is the current in this branch? This branch, what is the current?
Sorry.
What is the current in this branch? 5. What you say?
so -5
It is -5 volts.
Or current I'm asking, current in that branch. I'm asking, tell me the current in that branch.
Will that be 0?
Oh, why will that be so? Think and tell me.
Will it be 1/-2 ampere?
1/-2.
Yeah.
No, don't guess, use logic. Yes, see. Focus on this junction. How much current is coming?
Half ampere.
How much current is leaving?
So there 1/6 ampere will go.
What is the
So
difficulty? 1/2
yeah,
minus
1/2.
1/6.
Yeah.
See, if we forget these things, then business will be finished. So it's 1/3 ampere, all right?
Yeah.
Now tell me the current flowing in this branch.
Again half ampere is coming.
Just tell me the current in this branch. Don't tell wrong. What is the reading of the ammeter in this case? Carefully answer. I'm giving you option. ABCD 4 options are given. Current flowing in that blue branch. Arey baap re, what you all are doing?
I think it is 1 by 2 ampere.
Why?
Because we have 10 volts there and then 20 ohm resistor.
So you have 10 volt there, 20 ohm resistor. So current should be half, not through the battery, through the resistor that is already there. Yes or no?
Yeah,
When I draw a circuit like this, for example, I'm drawing a circuit. Focus here. Say I draw a circuit like this. Okay. So this is 10 volt, 2 ohm, 2 ohm. So can you say that, sir, across this 10 volt, this 2 ohm is connected? Yes or no?
yeah,
So
Yes,
current
sir.
in, like, what is the current through 2 ohm? What is the potential difference? 10? Like here is 10, here is 0, right?
yeah,
So 5 ampere. This is the current, right?
yeah.
So you say that, do you do V by R 5 ampere? Sir, current flowing in this branch is 5 ampere. No, no. This is the current flowing through resistor is V by I, V by R. So that is already there, half ampere already given. 20 by, 10 by 20. I'm asking through the current to the battery. Got the point or not?
Yeah.
Arey Baba, see, focus. Focus on this junction. How much current is going out of this junction? Half ampere is going in this way,
Yeah. And
half
half
ampere
ampere
going in
back.
this way. So how much should be coming?
So 1 ampere.
1 ampere is coming, na Baba?
Yeah.
You all want me to commit suicide or what? And you can
No,
focus
sir.
on this branch also. No, sir. Thank you so much. You can focus on this branch also. Half ampere is coming from this fashion.
Yeah.
From here, how much was coming? 1 by 3 we found.
Yes.
1 by 6 was coming.
Yeah.
So, and this is also part of that only. No? So how much will be leaving? 1 by 6 plus 1 by 3 plus 1 by 2, which is 1 again. Anyway, you do, it will get 1 only.
Yeah. Got it.
I'm giving one more question. Because capacitor is very much related to current. I told you previously on. Same kind of things are there in capacitors as was in current. At least in the first half of capacitor, things goes quite like it was there in current electricity. Second half of capacitors is quite independent of current. Still not fully independent. Here also we have equivalent capacitance like we had equivalent resistance. Charges on capacitor instead of current in the branches. Somewhat quite similar on. Just like you take zero potential, when we can replace those resistors. What I will do the next section, I'm just telling, I'll replace these resistors with capacitors. That's all. And instead of finding current in the branches, I'll tell you find the charge on the capacitor. That's all. The conceptually same, ditto same, no difference. Therefore, I don't want to move to that point if this part is not clear. Here current is conserved, their charge will be conserved. Quite similar, no difference. Therefore, one more question. Just a moment, one copy. 5 ohm, 10 ohm, 5 ohm, 10 ohm, 10 volts, 20 volts, 10 volts. I have only one question. Find the current through this branch. It's a new question. It is not like unlike the previous one. But this kind of question also we have discussed. Any hope? Or should I solve?
So now I'm solving. I took that point as 0 volts.
Remember I had told you that if you get stuck, you can take one point as x. Remember I told such a point? Okay, see, I'll solve. This point can be taken as 0.
Yeah,
Point how much?
1 ampere.
10 volts. All right.
Yeah,
Any other point can I take?
yeah, on the right.
So I can't take any other point as of now. Okay. When I'm stuck, when I'm not able to move ahead with potentials, in that situation, I can take potential of one point as x. I told this. I don't remember you were there not or not in the class, but I told one point you can take then as x. And if this point we take as x, then what is the potential of this point? Tell me. X plus 10, right?
Yeah,
This point x plus 20. Okay.
yeah,
Now what we used to do? We used to assume that current is moving away from this branch in all directions, and we would use the concept that total outgoing current would be 0. Summation of all the outgoing currents would be 0. This is what we would assume. Correct?
yeah.
Okay, here one small problem is there. That part is wrong. Okay, problem is current in this branch will be difficult to tell. Current in this branch is a bit difficult to tell. Okay, for the time being, one thing that can be done. Okay, for the time being, one thing that can be done is we can tell that current in this branch is at least 2 amperes, right?
Yeah,
This so we can tell, na? Sarakshi, because this is potential difference is 10, this is 5.
हाँ सर
That हम directly कह सकते. All right, now you see what I will do. Now it's a bit tricky. Focus here. So, all right, 2 ampere is there, no? The 2 ampere is already coming. All right. Current, this will be that is okay. Let us try to solve it. I hope you all can understand. So what is the current flowing in this branch, the leftmost branch? We're assuming current is leaving that branch. 10 minus x plus 10 by 5, right? Potential difference by resistance. Clear?
Yeah.
Sure? Yes or no? Clear, no?
Yeah.
Yes, sir.
Okay, current flowing in the bottom branch vertically downwards is 10 minus x plus 20 by 10. Yes?
Yes.
Understood?
Yeah.
Okay, then current in the rightmost branch is directly given 2. All right? Plus, we need to know the current in the green branch. All right? So if I assume that the current in the green branch is I, so I need to write that in terms of x. Right or wrong?
Yeah.
So now you see, if I'm assuming that 2 ampere is coming in this fashion, I is coming in this fashion. So what is the total current coming in here? I plus 2, right?
Yeah. I plus two.
So current, now you see, current in this branch is a summation of current through these two green branches. Agreed?
Yeah.
If I assume that current is flowing from both those branches, it is combining in pink, right?
Yes.
What is the current in the pink branch? So what I will do, rather than writing the individual current in the two green branches, I will directly write the one in the pink branch. Okay,
Okay.
it's logical.
Yeah.
Current going through those two green branches combine only and come through pink branch. So I'll directly write the current pink branch going away in this fashion because it is easier to write in terms of x. So it is 0 minus x by 10. Yes, current going in that branch. We are
Yeah.
I mean, assuming the direction like coming like this, and then finally the pink branch will have current flowing from 0 to x like that, because current has to go outward. That's what we assume. Okay, so it was a bit tricky. Data I gave randomly, so that's why. But understood, na?
Yes, sir.
Yeah.
All of you can solve. So before solving, see, 10 gets cancelled anyway. This is going to be multiplied by 2, so minus 2x plus how much? Minus 10 minus x. So this is minus 10 minus x, and this is minus x. Got the calculations? Check once. Understood or not? Multiplied by 2 on both the sides. Understood or not? Tell me.
Yeah. Understood.
Sure.
Yeah.
Minus
Yes,
2.
sir. Understood.
This is minus 2.5 volt. Then we can calculate the current in all the branches. Okay.
Just one thing. Why did you equate all of these to 0?
Because the current is coming something, then it will leave something also. Huh? If current comes at a junction, then something can leave also. Can get distributed and leave, right? Yes or no?
Yeah.
Say 10 ampere is coming, then 3 ampere and 7 ampere can get divided also, right?
Yeah.
If I assume that all the currents are leaving only, what does that mean? Because no current came only, it means summation of all of them should be 0 only. Total incoming current is 0, that should be equal to total outgoing current also.
Yeah.
That is the logic. Like in this case of the total incoming current was equal to total outgoing current. Here also we use the logic that let all the current go away from that particular junction. We can assume that no harm. If all the currents are leaving that junction, the summation should be zero because nothing is incoming. So total incoming should be equal to total outgoing. That's what we use. Okay.
Yeah.
See how this is related in capacitor. I'll show you. You all have understood. So I'll take the first question. What was that? So, battery was in which format? Up or down? Diagram is same, right?
Yeah.
Okay. What was the batteries? Tell me quickly. Battery ka, what was the value for the battery? The diagonal battery, what was the value? 10 volt, 5 volt. So say this is 2 microfarad, 4 microfarad, 2 microfarad. You have to tell the final charge distributions in these capacitors. Can you try?
Yeah, we'll try.
You have 1 minute. You can write the potentials and you'll get everything. First one got?
Yeah.
Okay, what was the answers you got? Tell me.
I don't know if it is correct or not.
No
But
problem.
for the 4 microfarad, because we have 5 volts, Q is equal to CV. So right one 20 CV and left one minus 20 CV, like that.
Yes, correct answer, but just a small mistake. See, signs you are telling. While you are telling correctly, see, this will assume 0. Tarakshi
Yeah.
clear? Tarakshi इसको 0 ले सकते हैं, right?
हाँ सर, ले सकते हैं।
This potential will be how much?
10 volts,
10, है ना? Because we are going like that.
Yes sir,
This will be how much?
5 volts.
5.
5. So which is at a higher potential, left one or right one? For 4 microfarad, the left plate is at a higher potential or right one?
Left one.
Left one, right. This will be plus, this will be minus. So what is the
Okay.
potential difference across the capacitor? Potential difference is 5.
Yeah.
Q equals to CV. So V is delta V is 5 and C is how much? 4. So what is Q? 20 microcoulomb.
20 sir.
Now the left one will be plus,
Yeah.
right, plus 20 minus 1. Finished. First one finished. Okay. For the left 2 microfarad,
For the left one, uh, the top one will be plus 10 CV and bottom one will be minus 10 CV.
plus 20 microcoulomb and minus 20 micro.
Yeah, sorry, 20, not 10.
Potential difference is 0. So Q equal to C into V. Again, potential difference is 10. And 10 minus 0 is 10. And C is 2. Clear this much?
Yeah,
Tell for the
Yes,
right
sir.
one.
5 twos are 10, then the top one
So
will be 10
10.
CV and bottom one will be minus 10.
So plus 10 minus 10. Clear?
Yes sir.
Yes, sir.
Solve the second one. See, if you don't know this voltage method, the question will seem very tough for you. Today you are knowing how to put 0 and everything, therefore you are doing. Tomorrow also you should be confident that you have to remember the method. If you forget the method and start solving, then finish. So you have to take 1 0 and then start. Question number next one, solve quickly. You have 1 minute to solve that. Sharp 1 minute. Not stop. 20 seconds gone. 30 seconds remaining.
सर हो गया.
20 seconds remaining. Okay, very good. चलो जल्दी start करेंगे. So, what is the charge on 10 microcoulomb?
So उस पॉइंट को 0 माना है.
Yeah. What is the charge on 10 microcoulomb?
Left one is 200 CV and right one minus 200.
Plus 200 and minus 200. Okay.
So 100, yes sir.
Then this one will be how much? Okay. For the top 5 microfarad, charges will be how much?
Left is 100 CV, right is
Wrong. See, the top
So
potential will be
50.
what? Minus 10.
Yes sir.
yeah,
So what is the potential difference? 30.
30.
The potential at 20 or minus 10, what is the difference between them? 30,
Yeah,
na?
30.
30, yes sir.
So the right one will be minus 150.
Yeah, minus
Left one will
150
be
and
plus
plus 150.
1.
Plus 150.
This is the steady state charges. Charges finally. And on the right 5 microfarad quickly.
Minus 50, right?
Minus 50, yes sir. Plus 50.
And bottom plus 50.
Clear?
Yeah,
One more question. Last question. Quickly write down this question. Battery write down 10 volt, 10 volt, 2 microfarad, 3 5. Now try to find out the charges. Just quickly write the question, then I'll tell you. Quickly write and then let me know you have written. Then question written.
Yes, sir.
So written.
Okay, now you see how to proceed. Again, it's asked find the final charge on the capacitor. So, which potential should we take 0? Let us take this one. Any point we
Yeah.
can take 0. No. So this one will be how much? 10.
10 volts.
This is how much?
10
10.
volts.
Are we stuck? So we are stuck. Okay, we can't go anymore. Here and there we can't do. So now we'll take this to be x. All right. And we'll assume like we used to assume that this much is clear, na x.
Yeah.
We'll assume
Yes,
that
sir.
x is at a higher potential, so the charges will be going in all the directions. We'll assume that, like we assumed in current. Same fashion, no difference. Okay, very easy. So what is the if I assume this to be x, what is the charge on 2 microfarad? And of course, one more thing. Wait. One more thing. If I assume x to be highest potential of all, we can assume that no harm. So this will be plus, this will be minus.
Yeah.
This will be plus, this will be minus. This will be plus, this will be minus. Okay. Now, what is the charge on the left 2 microfarad? Q equal to C into V. So C, what is V? X minus 10. Agreed?
Yeah.
Okay.
Yes, sir.
Plus the bottom 5 microfarad, what is the charge? C multiplied by V, that is X minus 0x. Got it?
Yeah.
And for the right one, you tell.
3 into x minus 1.
Equals to how much? This should be equal to 0. I'll tell you why.
0.
Yeah.
Yes, sir.
I'll explain you why. See, try to understand. When the battery was connected and initially the capacitors are uncharged, the portion, the plates which I'm drawing, they were uncharged. Try to understand this portion that I have drawn. I have taken one plate of each capacitor. They are not connected to the circuit. These 3 plates which I have taken into this color, they are not connected to the circuit. You're able to see or not? Like the
Yeah.
charges won't jump from one plate to that plate. I told you in the last class, the charge after it reaches one plate, it doesn't jump to another plate.
Yeah.
These 3 plates are independent, right?
Yeah.
Everybody understood this?
Yes,
Yes.
sir.
So initially, what was the charge on these plates? 0. The capacitors were uncharged. It is just connected to the circuit and final charge is asked. So if initial charge on those 3 plates will be 0, final charge also on those 3 plates will be 0 only. The charges will not jump from the external plates to within the colored plates that I have drawn. Charges will only rearrange from one plate to another. Overall charge will still remain 0. Therefore, we have equated it to 0. This is the logic. In current, the logic was total incoming equal to total outgoing. We assumed all outgoing only. So total incoming should be 0. I mean, if we assume total, all the currents are outgoing only. Nothing was incoming. So incoming was 0. So summation of total outgoing was also 0. But here, that is not the logic. The logic is these plates are independent from the external world. So initial charge was 0. So final charge on this plate should also be 0 only. Therefore, on the right hand side, it's equated to 0. And they are positive plates. Yes or no? Not understood. Zara? Sarakshi, clear or not?
Yes, sir. Clear. So, थोड़ा आवाज कट रहा था.
आवाज कट रहा है. अभी समझ में आया ना? फाइनल चार्जेस 0 होगा
हाँ
प्लेट
सर.
पे.
हाँ सर.
तो वही लॉजिक है. ठीक है. अब यहाँ से x निकाल सकते हैं. And find the value of x. See how we'll find. So 2x minus 20 plus 5x plus 3x minus 30 equals to 0, right? 7x, 10x. 10x equals to 50, so x equals to 5. So write down x equals to 5, right? Now once x is found, then I can find the charges on all of them. ठीक है, निकालेगी चार्ज. निकाल लेंगे ना चार्जेस। ये 5 वोल्ट हो गया, ये 10 वोल्ट हो गया, एंड दिस इज 10, 5, 5, this was 3. We can find the final charges, right? Capacitors are one capacitor. Are you can find or not, Re Baba?
Yes, sir.
Everything is written. P equals to CV. And you have found X as 5. No problem. Okay. So we have found X so as 5. So what is the potential difference? 5, 5 2s are 10. That's all. And yes, when you have found this as 5, so this will be plus, this will be minus. Okay, now?
Yeah.
So
Yes,
do that
sir.
careful. And similarly, this will be plus, this will be minus. And here will be 15, 15, 15, like that. All right. And this will be plus,
Yeah.
this will be minus, 25, minus 1. Clear? Understood everything?
Yes, sir.
Yes, sir. Understood.
Good. Now you all can leave. We'll finish up the class. Any doubts so far?
No, sir.
No, sir.
Hare Krishna, Hare Krishna.
Hare Krishna, Hare Krishna, Krishna
Ram.
Krishna, Hare Hare, Hare Rama, Rama Rama, Hare.
Thank you.
Hare
Bye.
Krishna, sir. Thank you.
Thank you, sir. Have a nice day.